So, what?
Let's start with the intro.
So our indie lab, we were trying to see how different materials and thickness affected sound, pressure, and intensity.
So it's done.
And so we used a microphone and a decibel reader, and we measured the sound pressure and intensity before placing different materials in between the source and the microphone. And then we compared the data and looked at how pressure and intensity were affected by different materials.
Okay, and before we talk about how it affected it, let's look at some graphs, some stuff.
And so that was a graph of
Pressure versus time.
yeah, sound pressure versus time, and you can see like the rarefactions and where the waves hit.
And then let's look at two different thicknesses. I don't know which one I just did. This is 10 centimeters. Oh, is it? Oh, these are all.
So what did you do to cause the sound?
No,
We had, you know, like, did you use the dog whistle for that?
yeah, it was just
the
like
dog
a
whistle,
dog
like
whistle.
an app on iPhone play the
And
same
you
song.
played it like into a piece of wood, or?
Like we had like
played it
a.
and then put the wood in front of the microphone.
Okay.
And see, that's a different thickness of wood.
You can see that it's smaller pressure. It's thicker wood. And then I don't know if I want to show them any other wood ones.
No.
Or let's go back to the PowerPoint. Alright, so from the graph we can tell that thickness, when we know, we know that thickness isn't like the main effector on sound pressure and intensity, but we do know that it does have an effect because the thicker the material, like the more wood we put in between, I mean, we kept the distance constant so it wasn't distance, but the more wood we put in between the microphone and the sound, the less pressure and intensity there was read by the microphone.
And so we also used different materials, like we used cardboard. I think we had one with glass, and yeah, we used cloth. And the density had a lot more impact on the sound pressure and intensity. And the denser the material is, the slower sound will travel through it, which was pretty obvious. And we had intensity equal to pressure times velocity, so the slower velocity would decrease the intensity.
Is that all we have on here? Because our formatting is not. Huh?
I thought sound travels faster.
Yeah, we weren't. Our density we had a little bit of trouble with, but do you have the conclusion on here, or is it?
Ollie had it on the PowerPoint.
It's not on PowerPoint.
Oh, okay.
I wrote it up separately. Let me pull it up. Sorry, 1 second.
Do you have an equation that relates speed to density of a material?
We didn't find one.
We didn't.
Do you guys have one
We didn't
in mind?
really
Root
focus
FT
on-
over mu naught.
Not mu naught, but mu.
Yeah.
So it depends on density, but it also depends on whatever Kevin said FT is.
The tension of the air.
The tension of the medium,
The median.
right?
Yeah,
Medium.
which is the air.
I'm pulling equals the speed.
Yeah.
That's velocity.
Velocity equals root F2.
Okay. So pretty much, we just found out from our data that the sound pressure and intensity is, I guess, would be directly proportional to the thickness, because the thicker the material was in between the, actually that'd be inversely proportional, sorry. The lower the intensity and pressure would be.
And then one thing that we thought could have affected it is we had, I think there was a slight gap between the microphone and the wood, and so it's like, because like it would roll a little because the microphone is not direct, like it's not flat, and so it might have read it through the air instead of through the wood.
So that's, yeah. So
Questions for these guys?
error.
Thank you.